So now that we have a sense for where this definition came from, let's actually try and use it. Now, we were looking at the function x squared plus 1. So let's write that down. F of x equals x squared plus 1. And then let's just take, that's okay. We know what this is. Well, what about this? F of x plus h. And I feel like this part of that expression is what trips all calculus or a lot of beginning calculus students up. It's a little bit of an odd expression, but what it means is it's just we have some function f, and instead of x, we're substitute everywhere you see an x, we put an x plus h. So instead of x squared, we have x plus h squared. That's our input to the function instead of x. So x plus h squared plus 1. And then we'll simplify this. So that means x plus h times x plus h, x squared plus 2xh plus h squared plus 1. All right, so now we've got that. H is just h. So we can plug into that expression. I have f of x plus h, which is x squared plus 2xh plus h squared plus 1 minus x squared plus 1. That's f of x. Right? This is f of x plus h. This is f of x all over h. And then we can just simplify things. We see we have x squared minus x squared, so these will go away. We've got 1 minus 1, and we're left with 2xh plus h squared all over h. There's an h in both terms in the numerator. Factor that out. We've got h times 2x plus h all divided by h. These h's cancel. We've got 2x plus h, and finally, just for this little expression, we've got this bit of our definition handled and cleaned up. Last thing is to evaluate this piece as h goes to 0. And for us, we're just going to look at this. Okay, well, if this were 0, we've got 2x. And the derivative of that function is equal to 2x. And if we were interested about the derivative at a point, now we have an expression that we can just substitute that in for and interpret it as the slope of the tangent line at that point. All right, let's do a couple more. So now another similar expression, x squared plus 2x plus 1. But the routine is the same. We've just got to kind of take our time, relax, and find the different pieces. So, we know what f of x is. It's x squared plus 2x plus 1. We need f of x plus h. So everywhere we have an x, we're going to substitute x plus h. And simplify. So x squared plus 2xh plus h squared plus 2x plus h plus 1. And now that we have, here's f of x plus h, here's f of x, we can use our definition. It's f of x plus h minus f of x. And we can already see that we're going to have x squared minus x squared. This will cancel with this. Our 2x's will cancel out. Our 1's will cancel out. And we'll just be left with 2xh plus h squared plus h all over h. There's an h everywhere in the numerator, again, as there usually will be. Our h's cancel. We're left with this expression, 2x plus h plus 1. And now we make that argument about h going to 0. So this will go away. What are we left with? 2x plus 1. Okay, and that is the derivative of f with respect to x. All right, so depending on the function, you know, these expressions may or be less unwieldy or more unwieldy. Final one, let's look at a cube. All right, so we have x cubed minus 2x plus 1. Again, we just got to take our time and find our two pieces, f of x, that's x cubed minus 2x plus 1. We know that. So what's f of x plus h? Well, x plus h cubed minus 2 times x plus h plus 1. That is going to give me x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x minus 2h plus 1. And again, we see that we'll have an x cubed and x cubed cancel out, a 2x minus 2x and minus 2x, and a 1 and a 1. And all right, so 3x squared h plus 3xh squared plus h cubed minus 2h all over h. Again, there's an h in everything in the numerator. Factor those out and cancel. We're left with the expression 3x squared plus 3xh plus h squared minus 2. And again, we make that argument now as h goes to 0. So this goes. We're just left with 3x squared minus 2. All right, but again, I think that this is always the tricky spot for initial encounters with the derivative or even continued ones. Okay.